Let's talk about .NET types. First of all, in .NET, all of our types are going to derive from system.object. This is the hierarchy. So this is going to be easy to figure out. This is a base class, and we'll describe that terminology later. But if everything derives from object, it makes things a little bit easier. This is like the lowest level that we can have. So furthermore, in .NET, we're dividing up into two different types. We're talking about value types and reference types. Variables that are value types, these are going to directly contain data. Now, when we use variables that contain reference types, these are going to store references to that data. So this is referencing the memory location where we can find the actual data. And these are more so known as objects, but they're both known as objects because they both derive from system.object. But reference types are going to include your classes, your user-defined classes, classes that are already defined by .NET, interfaces, which is an object-oriented feature. We'll see that later. Arrays, if you're familiar with programming, you have arrays of just like buckets of values that you can reference in order, and we'll see arrays in great detail. Strings are normal. If you're programming, you're putting your text into strings. So this is a reference type. Delegates are like C function pointers. If you're familiar with working with database APIs, writing them in C, then you're familiar with working with delegates. We'll talk about that and other types that can come up. So we'll see a lot more in reference and value types, the differences between the two. Reference types can actually point to the same memory location. So you can have two different objects pointing to the same memory location, and therefore they point to the same data. So with value types, you're assured that this is pointing to one data, to one value there. Now, with value types, you have many different types of value types. You have Boolean, bytes, chars, and then you have a series of integers, 16-bit, 32-bit, and 64-bit. The bytes and the chars, these are 8-bit. And then it moves up into higher availability of numbers from there, singles and doubles. Enumerations, we'll see. Numerations are great. They're a good way to actually work with text in your programming instead of actually referencing raw numeric data. And we'll see that as well. We'll just take a quick look in Visual Studio.NET at what an enum looks like. We can see here that we have an enum, a color, just like if we were putting a class, but we put enum. And then you can see we have red, green, and blue. These values here, we don't have to reference those values in our program. We know that if we want to reference a red color, we just reference the number 5, but we can just reference it as red. And same thing, if we want to reference what is going to work as green, we can just reference green instead of actually referencing that number 10. So when we actually go to use it, we can say color.red. And this is actually going to output the value that we see here. Red would be 5, green 10, and then we have blue. So those are enums. They can be quite handy and useful for many types of programs. We'll see more. Structures are great too. They're like lightweight classes that we're going to see. Lightweight classes that have value. They're actually objects, but they're not reference types, which allows for a lot of functionality because you can deal with reference types and value types. If you're confused a little bit about the two differences between reference and value, we're going to explore that in great detail coming up. Then with structures, this looks similar to working with classes, except you're working with the struct keyword. And then you can access data. You can put data members in there. You can also put your methods. And then you can reference by creating a new instance of a structure. And then just reference those variables. There are advanced structs as well, and we'll see them later. Of course, you can have decimal and others as well. So we'll just continue forward. We'll go into the data types because data types are always very, very important for the intrinsic, the simple data types. We have bytes, signed and unsigned. We'll take a look at that, what that means, the difference between the two. We have signed and unsigned shorts, which are 16-bit integers with a certain value that you can see here, a range of numbers. Then we have our 32-bit ints, unsigned and int. You have the .NET base types right here in the middle. And then you have your C# equivalent keyword. Longs gets higher and higher into large numbers, and then we have char, which are the unsigned 16-bit integers that represent Unicode characters. Then we have a single, which is actually a float, and this is 32-bit precision, single precision, and it has a nice range for us. Double is even bigger, 64-bit double precision, and then you can't forget Boolean, which is true or false, and this helps out quite a lot. And finally, decimal, 128-bit ranging from 1 to 10 to the power of 28, which is pretty big. So if we look in our object browser really quickly, View, Object Browser, if you want to get familiar with some of the types, go into Microsoft Core Library, System, and then you can find your types here by just referencing those names like I mentioned. You see N16, 32, 64, and you also have the unsigned versions of those further down. So just look for those references and then you can see the equivalent objects that are associated with it. You can see that there are methods that are available to you that you can work with, which come in quite handy. We'll see those in a little bit, exploring those in great detail.